this. And if you've got questions about things, come see me or go to the Math Center or see Logan, see our professional tutor in the Math Center as well. All those hours for Math Center hours and Logan's hours are posted on Moodle. But again, the material is going to get more involved as we go forward. We're going to build on what we've learned, add to what we've learned as we go along. So I would encourage you to go back through things, see what you've missed, and come ask questions about it. I'm happy to meet with everybody individually and go through the things that you missed on the exam. I want to make sure that everything is good to go going forward, making sure that understand what you missed, understand what's going on, all those ideas. So let's talk about new stuff today, but I will ask if you have any questions on the transformations of graph stuff that we finished up the other day, the section 2.6 things. My plan is to give you a more of a take-home quiz idea over that material. I'll have something either posted on Moodle or on WebAssign, one or the other, on Friday, and you'll complete it over the weekend for that. Okay, so I'll give more information about that on Friday. All right. Well, let's talk about new stuff today. Basically, creating new functions out of old ones, if you will. So that's what section 2.7 is all about, is combining things. So the first part of this section is doing arithmetic, if you will, with functions. Talking about how do you add two functions together, how do you subtract two functions, multiply and divide two functions. So we'll go through those definitions, do some examples, talk about how we look at domains of these things, and then we'll get into another operation of combining functions that's a little bit more involved. So these hopefully will be relatively straightforward when we talk about how to do these four arithmetic type of operations. So again, what we're looking at for these definitions here is looking at what the outputs are supposed to be, right? The input's going to be X. The output is going to be something. If I want to add two functions together, basically what we're going to do is we're just going to add the outputs. So when we have this notation is just for the notation for the sum of f and g. When we do that addition, the output for the sum of the two functions should be the sum of the outputs. So just adding your f and your g outputs together. So you can probably guess how the next ones are defined. What do you think of f minus g of x is going to be? Yep, f of x minus g of x, good. F times g of x should be f of x times g of x. And finally, f over g of x should be f of x over g of x, good. Those four arithmetic operations are what you would expect them to be, right? If I want to know what the output of the sum is, I'm going to do the sum of the outputs. If I want to know the output of the difference, I'm going to do the difference of the outputs, and so on down the line. They were exactly what you would expect them to be. So for this first example, we have arbitrary functions f and g, except for the fact that we know what the output is when we plug in 2 for f, and we know what the output is when we plug in 2 for g. So according to our definitions, if I want f plus g of 2, what should that be equal to? Say it again. Should be, I just didn't hear. It should be -1 at the end, right? Because according to the definition, f plus g of 2 is equal to f of 2 plus g of 2, right? We're told what f of 2 is. It's -12. We're told what g of 2 is. It's 11. When we add those two things together, we get -1. So we just take the outputs and add them together. What do we get for f minus g of 2 then? It'd be a -23, because again, according to the definition, What's f minus g of 2 equal to? It'd be negative 12 minus 11. So the definition says it's going to be f of 2 minus g of 2, right? That's how we would rewrite it. And then the values are negative 12 for the f of 2 and 11 for the g of 2. Subtract those two together, we get negative 23. How about f times g of 2? Negative 132. And how'd you come up with it? Yeah, the negative 12 times the 11. So it's f of, so your f times g of 2 is f of 2 times g of 2. So we'll get negative 12 times 11. I'll give you negative 132. Finally, you tell me the last one, f of g, f over g of 2 is going to be negative 12 over 11, because it'll be f of 2 over g of 2. And there's not a lot of simplifying you can do with the negative 12 over the 11. That okay? Questions on that at all? Yes. What do you mean, what's the point of the two? Well, so this means that we're plugging in 2 for x. We just don't know what the functions are explicitly here. All we know is for certain is that when we plug in 2 for x, we're supposed to get out negative 12 for y. We plug in 2 for x, we're supposed to get out for the f. We plug in 2 for x, we get out 11 for the y for the g. But I don't know what the functions are explicitly. But I would know things like the point 2 comma negative 12 would be on the graph of f. I would know that 2 comma 11 would be on the graph of g. Those kind of things. But for this specific example, we don't know what the explicit function is, so there's not a lot we can do with getting an actual output out for it. Or, sorry, an actual output out for anything besides 2. What will we get for the 4 answers for this next example? What would you get for f plus g of negative 2 in the next example? Okay, and how'd you come up with it? Good, yeah, it's a 1 plus the negative 2, right? This says add the outputs. So you have 1 plus negative 2 gives me negative 1 for that one. What about the next one? It'd be positive 3, right? Because it'd be 1 minus a minus 2. For the third one, negative 2. And the last one, negative 1/2. That okay? All right. So let's talk a little bit about then some important pieces of information about the function if you're going to do these arithmetic operations. So we've talked about domain. Remember, domain, again, is what you're allowed to plug in for x, right? So the big problems that we've had with domain so far, the 2 big problems we've had with domain. One is, what's wrong with square roots? What can't you take the square root of? Negatives, right? What can't you divide by? 0. Those are the big 2 domain issues that we've had, right? Okay. So notice that when you're plugging something into the sum, I've got to plug it into both f and g, right? So whatever I plug in for x has to be in the domain of f and the domain of g, right? It has to be allowed to be plugged into both of them. Same thing for the difference, same thing for the product. So the domain for those is going to be all x's that are in the domain of f and the domain of g Has to be in the domain of both of them at the same time. Nothing else is going to go wrong, right? When I do a sum of things, I don't have any issues. When I do a difference of things, I don't have any issues. When I do a product of things, I don't have any issues. Oh, I don't have any new issues, I guess I should say. Right? I still have to worry about things like taking square roots of negatives or dividing by 0, but I don't introduce any square roots or divisions when I do these three operations, right? What about the fourth operation that we talked about? Do we have any issues there that might pop up? Yeah, the g of x part can't be 0, right? So the domain here is still the set of all x's that are in both the domains. So still in the domain of f and the domain of g, and so that our g of x is not equal to 0. Because we're introducing a division, I need to make sure that whatever we plug into x doesn't give us 0 in the denominator. So it adds a little extra layer that you have to worry about when you do the division. Now the good news is that if you're asked about domains, typically you're going to have explicit functions given to you, like we have in the next example. You're going to combine the functions together, and then you're going to look for the domain. So it's not going to be as confusing as it sounds by what I'm doing with the definitions here. So if we do this next example, this problem asks you first to find what is the sum of f and g. Well, again, remember f plus g of x is defined as f of x plus g of x. So what will we have in this case? Good. Literally just add the two together, right? Negative 5x is the function f of x. X squared minus 1 is the function g. And then typically we would write this a little prettier by putting the highest degree term first. It's not necessary, but typically we write it a little bit prettier. So we would write it as x squared minus 5x minus 1. Right? So there's what the sum of those two functions is. Now let's just look at the function that we just created and ask what's the domain. Do you see any square roots here? No square roots? Do you see any denominators that will be 0? No. So what do you say the domain is here? Negative infinity to infinity. Good. So our domain here would be minus infinity to infinity. So again, I would encourage you, rather than trying to say, oh, what's the domain here, what's the domain here, what's in both at the same time, literally do the operation first, and then look at the domain. Is the domain going to change if we did f minus g or f times g? Would the domain change, or would the domain stay the same? Stay the same, okay? So your domain for the sum, the difference, and the product would be exactly the same. So if you were asked, what's the domain of f minus g of x, or what's the domain of f times g of x, it's still minus infinity to infinity. Okay? We didn't introduce anything bad when we do those operations. Okay? But let's look at part B. When we do f over g, again, what's the definition? How do we find f over g of x? Good, yeah, that's f of x over g of x. Our f of x in this case is negative 5x, and our g of x is x squared minus 1. So there's the function f over g of x. Did we introduce anything bad now when we did this particular function? Or potentially bad? that we can't have the bottom equal to 0, right? We don't have any issues plugging in numbers for negative 5x. We don't have any issues plugging in numbers for x squared minus 1. That's not a problem. The problem comes up is when the denominator is equal to 0, just like it was before, right? So if we set the denominator equal to 0, how does x squared minus 1 factor? Good, yeah, x plus 1, x minus 1, good. And so what values would make that equation equal to 0? Negative 1 and negative 1 and negative 1. Those are the numbers that x can't be, right? So what's your domain going to be if those are the numbers that x can't be? How do we write it in interval notation? Good. Good. Right, we need to delete the negative 1 and the 1 out of the minus infinity to infinity. So we write it as a union of those three intervals. Why do we use parentheses rather than brackets? You can't include them, right? That's not equal to negative 1 and it's not equal to 1. So we want to use parentheses on those. So our domain then is, like I said, the union of those three intervals, negative infinity up to negative 1, then negative 1 up to 1, and then 1 to infinity. But again, this is not any different type of problem that we asked before. All we're being asked differently here is to do the arithmetic operation first and then look at the domain. Any questions on that one at all? It's okay so far? Yes? No? Maybe? Yeah? All right. Let's look at the next one. Got a little bit more complicated in the next one. Our next one says find f minus g of 3. Again, by the definition, not worrying about what the functions are at all, how do you find f minus g of 3? What do you do? Yeah, the f of 3 minus the g of 3, right? So this says plug in 3 for x into f, plug in 3 for x into g. What do you get when you put in 3 for x into f? Square root of 3 times 3 minus 5, right? And g of 3 would be 4 over 3 plus 1, right? 3 times 3 is 9 minus 5 is 4. Square root of 4 is 2. 4 over 4 gives me 1, so we get 1 there. This one was asking us for an explicit value, right? Plug in the 3 into both of them. Next part says, let's just do f times g and see what happens without worrying about a specific x. Again, by definition, f times g of x is what? Yeah, the f of x times the g of x. So we would have square root of 3x minus 5 times 4 over x plus 1. And I'll just combine that into one fraction. So that's what we get when we multiply those two things together. The second part asks us for the domain. So what can go wrong with your domain here? 0 in the denominator is one of them, and what else? Yeah, the negative under the square root, right? So from the top, what do we, if we just look at the top, what do we need? Looking at the top. So the 3x minus 5 needs to be, yeah, the greater than or equal to 0 part, right? The inside of what's underneath that radical needs to be greater than or equal to 0, right? We can't take the square root of the negative and keep it a real number. What else do we need? If we look at the bottom, yeah, the x plus 1 cannot be 0, right? We need both of those things, right? We need to worry about the numerator and the denominator here. The first one, if we add 5 and divide by 3, we get that x is greater than or equal to 5/3. Notice that your inequality does not flip here because we would divide by the 3, right? We divide by a positive number. The second one says x cannot be what? -1. Does that matter for us if we look at the first condition? Is -1 greater than or equal to 5/3? No. So this one really doesn't affect anything, right? Because I have to have this anyway. So what's your domain going to be then here at the end? So is it this way? 5/3? Yeah, it's the other way, right? Because it's greater than. So we need the 5/3, the 5/3 to infinity. Yep. And why? They're just going to ask that. Why is it a bracket? Yeah, it's greater than or equal to it. That's exactly right. There's no worries about trying to delete out -1 because -1's not in that interval, right? Let's do the next one here together as well. The first one asks you to find f over g of x. What would f over g of x equal in this case? Good. Yep. So our f of x is square root of 6 minus x. Our g of x is x squared minus x minus 2. We're just doing whatever the f is over whatever the g is. So like in the previous problem, what things do we have to worry about? What do we need? Okay, so we need the bottom not equal to 0. I agree with that. Good, yep. So we can have a negative on the inside. So what's under the radical, the 6 minus x, needs to be non-negative, right? It needs to be greater than or equal to 0. And again, to get outputs that are real numbers, I can't do square roots of negatives. We also need to make sure that the denominator is not equal to 0 because we can't divide by 0. Right? That okay? Let's look at the inequality first. What if we solve this inequality, what do you get?
X is less than or greater to 6.
Yeah, x less than or equal to 6. Yep. Right? You can either think about it as subtracting the 6 and then dividing by -1 so the inequality would flip, or add the x and then just rewrite your inequality in the other order. What if we were looking at the equation x squared minus x equals minus 2 equals 0? What would you need to do on the left-hand side? Factor it. How does that factor?
X minus 2x.
Okay.
I have a question.
Yeah.
How is that not a -6?
It would be a -6 if I moved it over, but then you'd divide by the -1. If you were thinking about doing it this way. Right?
Oh, because it's a, yeah, I see now.
Okay.
Thank you.
Yep, you're welcome. What values make this equal to 0? 2 and -1. And again, that's what x cannot be, right? I need to make sure that we throwing things around. Those are the values that we cannot plug in for x. Those are the values that will make our denominator equal to 0, right? All right, so when we put all of this together, I need to look at both pieces. I need to look at this piece, x is less than or equal to 6, but also our x cannot be -1 and it cannot be 2, right? If I were to write, if I didn't have the first piece, if this weren't here, what would you tell me the domain is in interval notation? -infinity up to 6, right? Because we're looking at less than or equal to 6, right? That would be just this part to here, right? Are these numbers in this interval? Is -1 less than 6? Yep. Is 2 less than 6? Yeah, so those numbers would be in the interval. We need to delete them out, right? So how would we write this to delete out those numbers? Okay. And is it going to be a parenthesis or a bracket? Because not included. Good. Okay. Good. 2 to 6. And then the 6 will have a bracket on it. Erase that thing out of the way. If you like to think about it as a number line, the interval from negative and that was weird. Why did it go away? That was weird. The interval from it does not like me to try to shade things on here clearly. The interval from -infinity up to 6 would look like that, right? You'd put a dot at -6, or excuse me, at +6, and shade to the left. If we want to delete out the -1, which would be somewhere over here, I need to delete that out, and the 2, I would need to delete that out. So we'd have open circles, right? We delete those out. So you'd have this interval, that interval, and that interval, which is exactly what we're writing down here. So this is just a picture representation of what we have here. Questions on that? How would the second part differ? What would G over F look like? Good. It would just flip the fraction, correct? Now what do we have to worry about? Is there any issues with the numerator in this case? No. So this is fine. We can plug whatever we want into the top. So what's the only thing we need to worry about? The bottom. So what do we need 6 minus x to be? Okay, so can it be equal to in this case? No, because if it's equal to, it will be making the denominator 0, right? So we need our 6 minus x to be greater than 0, which means our x needs to be strictly less than 6. And that's the only thing we have to worry about because there are no issues with the numerator this time. So what would our domain be then in this case? And then what goes on the end? Parentheses. Yep, good. So notice the order in which you're doing the division is going to matter, right? In the first example, we had to worry about when the denominator was equal to 0, that x squared minus x minus 2 piece. When we flipped it upside down, we didn't have to worry about it anymore. What questions do you have on that? Yeah, Malachi. This one? Okay. Oh, okay. Other questions? So on the next page, I think we're talking about a new operation, composition. Yes? I'm writing that down. Or okay. So notice that in the notation for that composition, you've got that circle in the middle, right? So it's composition. The way we would read that is F composed with G of X. So when we do composition, what we're doing is one function and then followed immediately by another function. So an example of that would be if you get up in the morning, you're barefoot, you want to go outside, maybe you put on socks and then you put on shoes, right? It's possible to put on socks and not put on shoes, right? It's possible to put on shoes and not put on socks. Usually you'll put your socks on and then your shoes. That would be the composition of those functions. Do it the other way around, put on your shoes and then put on your socks would look silly, but you can do it, right? But that's what we mean by composition of functions. You do one function after the other. So the output of the one function is going to be the input for the other function. That's what composition means. So the way we do this is the X first goes into the G. That output then goes into the F. So it's F of G of X. Is how we typically say that. F of G of X. When we're worried about the domain, usually we just write it in words, but we'll do it after we've actually done the operation. Where does the X go into first in this composition? In the G, right? So the X has to be in the domain of G to start with. Oops. So this will be the set of all X's so that X is in the domain of G. But once we plug in X, the output comes for G of X. Where does that G of X need to be now? In the domain of F, right? So and, we have an and part here. G of X is in the domain of F. Personally, I think this is a little bit more confusing in words than just doing it. So we'll just do some problems here and then talk about how we get the domain and those kind of things. So again here, in this first example, we're not given explicit functions, but it's still asking us to find what F composed with G of 1 is if I know that F of 2 is negative 10 and G of 1 is equal to 2. Again, according to the definition, what is, ignoring the rest of the problem, according to the definition, what is F composed with G of 1 equal to? F of G of 1 in this case, because we replace the X with the 1. Okay. When it's written this way, where does the 1 get plugged into first? The G, right? It gets plugged into the G first, right? So according to the information we're given in the problem, what is G of 1 equal to? 2. So we would replace that G of 1, that whole thing, with the 2. And then again, here, according to the problem, what is F of 2 equal to? Negative 10. So again, when it's written this way, the 1 goes into the G first, the output then goes into the F. Let's do the next one. This one we're given explicit functions. So F composed with G of 1 is F of G of 1, just like it was in the previous example. What does this say to do? Plug in 1 into the G, right? Let's do that. What do you get when you plug in 1 into the G? Well, it says that's 1 to the 2/3 power plus 4. Right? Take out the x, put in the 1. What does 2/3 power mean again? There's different meanings for the top and the bottom of the fraction with the exponent. If that 3 weren't there, the 2 would tell you to do what? Square it. What does the number in the denominator tell you in the exponent? Cube root, right? Remember, the one in the denominator tells you what root to take. So this says do the cube root of 1 and then square it. Or square 1 and use the cube root. Either way works. What is the cube root of 1? Squared is 1. Add 4, you get 5. So this becomes f of 5. And then what does this say to do down? Yeah, put 5 into the f. And so we get 14. Let's do the next one. This one asks for G composed with F of 7. So by definition, what is this equal to? A G of F of 7, right? So where does the 7 go first? Into the X for F, right? So 1 over absolute value of 7 minus 5, the way that's written. 7 minus 5 is 2. Absolute value of 2 is 2. So we get G of a half. All right. Now what do we do? Yeah, so we get G, we get the square root of 1/2 plus 2, which would give you square root of 5/2. I do not care if you rationalize the denominator. You can leave it as square root of 5/2. That's perfectly fine. Nothing wrong with that at all. That one okay? So in the first two examples, we plugged in specific numbers. In the next example, it just says leave them as x's. So again, your definition of f composed with g of x is f of g of x, right? We agree with that? Okay. Now notice in the first two examples, I was very explicit about plugging in what the x is, but still making it look like g, right? In the first example. In the second example, I plugged in the x, but I still made it look like f, right? So same idea here. I'm just going to leave it as an x. Our g of x is 3x minus 1, so I'm just going to replace g of x with 3x minus 1. That's what it says to do, right? If I have an x, I take it times 3 and subtract 1. I'm just leaving it as an x. What does this notation tell us to do now? What am I going to do with this 3x minus 1? Yeah, I'm going to put it in for the x in the f, right? So remember, this tells me to take out the x and put what's ever inside these parentheses in for it. So this would be 3 times 3x minus 1 squared minus 5. It's literally what it tells you to do, right? Take out the x and put in whatever's in those parentheses. That's the composition. You could simplify it. You could multiply out the 3x minus 1 squared, distribute the 3, and subtract the 5 if you want to. But that is the composition. That is what we get. You can multiply it out if you want, but that is the composition. The rest of it's just doing the algebra that you've learned before. What about the other way around? What does that tell you to do? You do the f of x first, so this would be g of 3x squared minus 5, right? And what do we get here? Minus 1, yeah. And then you get, again, if you want to simplify it, you can, but that is the composition, right? We took out the x in g of x and replaced it with 3x squared minus 5. Remember, again, that's what this notation means. It says take out the x and put in this, whatever this is. Could be a number, could be a letter, could be an emoji, could be a Taylor Swift album. Doesn't matter what's in those parentheses. The notation says take out the x and put literally what's in those parentheses in for the x. Doesn't matter what it is. Right? Doesn't matter what the object is. Could be a number, could be a letter, could be whatever. Could be an oak tree. It doesn't matter what it is. You're going to take out the x and put in whatever, literally what's in those parentheses in for the x. Okay? And it doesn't matter that I wrote the same letter twice here. This says do f composed with f of x. Oops. If we write it out by the definition, what does that mean? Yeah, it'd be f of x, right? That's what literally it means. F of x is equal to 3x squared minus 5. And again, this now means take out the x in f and replace it with what's in the parentheses. So what do you get? Good, exactly right. We took out the x and replaced it with what's in parentheses. That's literally what that means to do. Again, if you want to, you can multiply it all out, but that is what the composition is. Questions on that one? Yes?
So would you accept that final form as like the answer on it?
Yeah.
Okay.
Yeah, absolutely. That is the composition. And in fact, the reason why I'm leaving it is because of the next part here. You have to be a little careful with domains in composition. Remember, the composition is, for the domain, you have to plug it into the inside function, and what you get out has to go into the outside function. Okay? So it's a lot easier to read domain off if you don't simplify it. If you simplify it sometimes, the domain might be goofy. So let's look at this. It says, what's the domain? Or find the g of f of x, and then find its domain. F of x in this case is what? The square root of x minus 4. Right? And then again, what does this tell us to do? Plug it in for x into the g function, right? So we would have square root of x minus 4 squared plus 4. That's unsimplified, right? If you were to simplify this, what would you get? what happens with your square root and your square? They cancel each other out. What would happen with your -4 and your +4? They cancel each other out. You end up with x. Okay? We agree? If I cover up everything in between, so cover up all of this, and you just ended up with x, what would you say the domain would be? All real numbers. That's wrong in this problem. Okay? It's wrong because it came out of a composition, right? I have to go back to the unsimplified form to figure out the domain. What can't you plug in here? Anything less than 4, right? I can't put in negatives. So even though after you simplify, it looks like the domain is all real numbers, from this part right here, the domain is everything 4 or greater. Okay, I have to be careful. Right? Versus the other way around, if I do f composed with g of x, f of g of x, what's g of x in this case? X squared plus 4. So we do square root of x squared plus 4 minus 4, right? Underneath the radical, that simplifies to x squared. What do you get when you do square root of x squared? You gotta be a little bit careful. Actually, when you do square root of x squared, we get absolute value of x. Because if x is negative, you square it, you get a positive, don't you? And then when you do the square root, you keep the positive. Looking at this function here, that domain is all reals. It came from here. Is this ever negative? If I do x squared, is that ever negative? No. So the domain really is all real numbers. So notice that the domain here is different for one versus the other. So for next time, see if you can look at that next example. Come up with the domains. We'll finish off the last page, and then we'll get into section 2.8 as well. So again, like I said before, I encourage you to read through your exam, figure out what questions you have, come talk to me about it. I'm happy to chat with you, or see Logan about it, or go to the Math Center about it. Have a good one. If you didn't get your exam, I have them up here too if you came in late.